Yes, class, is this audible? Arif and Abdullah.
Yes, Miss, you're audible.
Abdullah, if it's better, I think if you could open up your camera also for the class. If you could open your video for today's class. I think it was informed to you that in your classes also you have to open up your video cameras. Now, see, kinetic energy we had done. We had done the basic work energy theorem. So work energy theorem was what? All the change in kinetic energy was equal to the work done. So this is basic idea of your work energy theorem. But we didn't do any numerical on this, no? Only this example I did where we had calculated the change in the percentage of kinetic energy. Quickly, let's complete with some numericals. We didn't do any questions on this. See here, how will we solve it? It is saying what? This is simply saying a bullet weighing 10 gram. There's a bullet that has been fired with a speed of 800 meter per second. So the speed of the bullet that has been fired, there's a bullet that has been fired, and the speed of this bullet is 100, is how much? 800 meter per second. No? 800 meter per second. This is 800 meter per second. Fine. Then it says it passes through a wall which has a thickness of 1 meter, and now the velocity decreases to 100 meter. Means this is the initial velocity of the bullet, and the final velocity of the bullet becomes 100 meter per second. And the distance that it had to cover in the thick wall, the thickness was 1 meter. Right, it was given, yes, 1 meter. So change in kinetic energy. Kinetic energy's formula is half mv square. So initial kinetic energy will become half mv initial square. Right, this is the formula. Half mv square is the formula for kinetic energy. So half mv1 square for initial kinetic energy, then half mv2 square for final kinetic energy. If this is final, then what will be the change in kinetic energy? It will be kinetic energy in final minus kinetic energy initial. This is how we'll calculate it. So change in kinetic energy will be simply, let's take half m common from both these. half m. So that becomes V2 square minus V1 square. So half mass is given as 10 grams. So we have to write it in kgs. So we'll write it as 10 into 10 to the power minus 3. This becomes kg, 10 kgs. V2 square. V2 we have as we have it as 100. So that is square of 100 minus square of 800. This is what we'll get. So if you put in here, you get 10 to the power minus 2 or 1 by 200. Also, you can write this as 1 by 200. And this becomes 10,000 minus 64,000. 64 and 4. This becomes. Now, when you solve it, you'll get your answer around 315 joules, minus 315 joules. Just solve and check. This becomes what? This becomes the change in the kinetic energy. Fine, this is the change in the kinetic energy. Did you understand what did we do? Final velocity you had. So with the help of final velocity, we calculated final kinetic energy. Initial velocity was given. So initial kinetic energy was calculated using half mv square. Both were subtracted to get the change in kinetic energy. First part, is it clear or not? Yes or no? Tarif, is it clear to you?
Yes, miss. Yes,
okay.
Clear.
And Abdullah, what about you?
Yes, ma'am.
Okay. So now work done by resistive force. Do we actually need to calculate work done by resistive force? If I have the change in kinetic energy, what will be the work done? Anyone? If I have calculated the change in kinetic energy, what will be the work done then? What was work energy theorem? C class, work energy theorem said that whatever is the change in kinetic energy is equal to work done. So I have calculated change in kinetic energy from the first part. Work done will be this only, minus 315, whatever value I have obtained. It was minus 315 only. So in the second part also, I need not calculate anything. For the second part also, work done is equal to minus 315 joules only. This is because of work energy theorem. Your complete theorem was this only. Now it is calculating average resistive force. This is the bullet. Bullet had covered the thickness that the wall has, that is 1 meter thick. The bullet went, and here finally its velocity decreased to 100 meter per second, which was initially 800 meter per second. If this is the case, this is 1 meter becomes the displacement that has to be covered by the bullet. So displacement is 1 meter. Work done is minus 315. Can we calculate force now by any formula you have ever heard of? Work done, force, displacement. Can we connect it? Yes, Abdullah. Any equation to connect it?
Ma'am,
Yes, Iram.
is it work done upon displacement?
Exactly. Good, Aaron. Work done is equal to force into displacement. Dot product of force and displacement only, no? So here's the angle will be what? Displacement is covered here. Resistive force will occur in opposite direction. This is the resistive force, average resistive force. So theta will become 180 degree. So work done. This is F dot S. This is what we had started with in work energy and power. So force dot displacement means Fs cos theta. Resistive force will resist the motion of bullet. The wall is providing a resistance to the bullet that is crossing it. So resistive force will be in opposite direction. Displacement is towards the right. Average force is towards the left. So angle is 180 degree. That makes it F into 1 into minus 1. Cos 180 degrees minus 1, which is minus 315. So minus minus cancels, force becomes 315 Newton. Use, connect all the relations that you have studied. All right, quickly note it down. Aram, your half yearlies are over.
Yes, ma'am.
So did you receive your score of the
No,
till
they,
now
they were
year?
not half yearly. They were just models.
Okay, they're just models. So half yearlies still left, Aram?
Ye no, we don't have half yearly this time. We have just finals. That will be in the month
Okay.
of January.
Okay, in the month of January. Fine. One more thing. Aram, now in your school, has the second book started?
Just a minute. I'll check.
Okay. And what about you, Tarif? In your school, what's the lesson that is going
Uh,
currently?
Now we are about to finish loss of motion.
You're about to finish?
Loss of motion.
Motion, laws of motion. Okay. And
Ma'am,
Abdullah? Yes, Aram, say.
we're currently on mechanical properties of fluid.
Okay, mechanical property. Fine. And Abdullah, in your school?
Ma'am, chapter 8, ma'am.
Chapter 8. Is this last for gravitation?
Yes, ma'am.
Okay. Now see, this was about kinetic energy. Now next topic that you have is potential energy. But before potential energy, one thing that is required is types of work done. This was left, types of work done. So see, first type of work done you have are the positive work done. Positive work done basically means, see, your formula is what of work done? It is F dot S, right? We take the magnitude of force, magnitude of displacement into cos theta. This is what we take. Now cos theta, here this is positive. Whenever you have cos theta as positive, it means theta has to be an acute angle. Acute angle, do you understand? Any angle that is less than 90 degree. So if your angle that is formed between the force and the displacement, this is less than 90 degree, we call it acute angle. So cos theta will be positive. If cos theta will be positive, your work done will be positive. So any angle where your theta is acute or zero, you can also take. For example, you can take this example. Let's say a ball that is falling. A ball is there, ball is falling. Freely falling body. Free fall we have done already. So free fall, same case of free fall. Here, mg is acting downwards. Ball is also covering the displacement downwards. So angle is 0 degree. You have positive work done. Right, so you can take any example. Secondly, you have negative work done. Just opposite to this, negative work done. So in negative work done, what do you have? Cos theta has to be negative. If in this formula, see, work done is equal to Fs cos theta, your cos theta, if somehow this becomes negative, if this is negative, then your overall work done can be negative. And for cos theta to be negative, theta has to be obtuse. Obtuse angle, do you get this? Obtuse angle is any angle that is between 90 degree and 180 degrees. This is obtuse angle and cos theta is negative. So work done will be what? Work done will simply be negative. The way, just take the example of the question that we did. Our work done was coming negative. Why? Because the bullet resistive force was average resistive force was in the opposite direction and displacement was covered in the opposite direction. Theta was 180 degree, we got -1, and so the work done also came out to be negative, -315 it came. All right, so work done, one more thing, one more type of work done is there. One last type, that is zero work done. Zero work done means when your work done is zero. Now, two things can happen for work done to be zero. Listen this carefully. Either it can happen, two things can happen for work done to be zero. In the formula, work done is equal to Fs cos theta. Tell me one value of theta for which work done can be zero. Value of theta for which work done can be zero. Yes, Tarif. When is cos theta 0? Theta is what value? Abdullah, when do you say a term is 0? What is that angle for cos? Cos 30 degree, cos 45 degree, which value of cos? Aram?
Cos 90.
Cos 90, definitely. Did you understand? Abdullah and Tarif. Cos 90 degree is 0. Agreed or not?
Yes, miss.
Cos 90 is 0. So if your theta is somehow 90 degree, no, let's say force is acting upwards, displacement is occurring over here in this direction. So angle will be 90 degree. For that case, you have work done as 0. Or the other thing can happen, if your displacement is 0, a body is kept. For example, if I keep this pen like this and nothing is happening to the pen, though I am holding it, but since even for hours if this pen is not moving, there will not be any displacement. If there won't be any displacement, it means there won't be any work done. So work done will also be zero. Summarizing, three cases are there. Listen carefully, class, before we start with proper conservative and non-conservative forces. Positive work done, theta means theta has to be acute, that is less between 0 to 90 degrees. For negative work done, theta more than 90 degrees, 90 to 180 degrees. When your theta is negative, cos theta comes out to be negative, your work done will also be negative. Last is zero work done. For zero work done, either theta can be 90 or displacement can be 0. All right, copy this quickly, then we'll start with the main part, that is conservative and non-conservative forces. Now, conservative and non-conservative forces, because this topic is directly related with your potential energy. Now, see, conservative forces, you have to understand what is meant by these conservative. Now, see, conservative forces are those forces. There are certain points which you have to remember. First is that whatever is the work done, it is independent of the path. Means if this is, let's say, this is point A. This is, let's say, the first path that has been covered. Or this object takes this path 2 to reach B. Or let's say the path taken by this is 3. There are 3 routes that are taken. If the conservative force is applied, then work done in 2, 3, and 1, all these 3 will be the same. Work done does not depend upon the path that has been traveled. It only depends on the initial and the final point. This is what is meant by conservative forces. I'll write down the statement as well. So conservative forces are what? Forces in which work done is independent. It's independent of the path traveled. Path or independent of the path. Now it depends on what then? These forces depend on what? If it is independent of the path, it depends on initial and final position. Initial and final position. Now see, for example, let's take some forces that are conservative. Gravitational force. Gravitation lesson is also there in your syllabus. Gravitational force, let's see. Now see, for example, there are many forces. I'll write down names of other forces as well. Gravitational force is there. You have electric force. Electric force you will study in the next standard. Then apart from electric forces, you have elastic forces. Elastic forces we'll do when we'll be doing mechanical properties of solids. There you'll see elasticity is a phenomena that is there. So these are certain forces which are conservative. So when you have these forces in nature, no, then your total work done, this does not depend upon the path that has been traveled. It only depends upon the initial and the final point. All right. Or you can take some more example also. Like electric forces there, elastic forces there, all these forces that are present. Now, see, if you take the example, let's say work done, there's an inclination that I have taken. At this point, a ball has started rolling, and at this point, the ball has landed. So, work done at this point will be minus mgh, or even let's take plus mgh even if you want. Here also work done will be minus mgh only, because this does not depend upon the path traveled. Or this is let's not write minus mgh. Let's write work done is plus mgh. This is one case. Now see, another same case. If the ball goes to this point and height is exactly h, here also work done will be mgh only. What did I say? It does not depend upon the path that has been traveled, whether it's on an inclined plane or on a plane path. So in both the cases, your work done will be the same. Fine. And work done by conservative forces, if it is for a closed path, like this was an open path. Initial point is there, final point is there, and your work done is only based on initial and final points. So you focused on initial and final, you didn't consider whatever the path was, be it inclined plane or direct. Both of them had the height h, so you wrote work done as mgh. This is clear. But if you have a closed path, let's say point A is the initial point, point B has been covered, then back to point A. This means what? This means closed path. If closed path is there, then work done by conservative forces, is 0. Why is it 0? Anyone? Can anyone answer? Why is the work done 0 in closed path? Any idea? Think about the formula. Why work done will be 0 in this case? What is the displacement if initial and final point both are same?
0.
0. Only Aram is active in the class. Only Aram has to answer all the questions. Even I asked you, Abdullah, to open up your video also. Please be attentive. Otherwise, it will be mandatory for all of you to open up your video and then sit in the class. Try to respond. See, wherever you're not understanding, just ask. I'll repeat the point. It is 0. If initial point is this, you take a turn, you come at exactly at this point, there is no displacement, so it is 0. That's why for closed path, you have work done as 0. Now, why are we classifying forces as conservative and non-conservative? There wasn't any use. Why did we classify it? We could study the way we were studying forces normally. It is that potential energy, the topic that is important for us. Mainly the fact is that potential energy is valid only for conservative forces. Is valid for only conservative forces. That's why we are just categorizing so that you know whether a force is conservative or non-conservative. So conservative forces included what? Net work done for a closed path will be 0. Initial final point will only matter. How the path has been covered, that is not mattered. That does not matter over here. But if we talk about the non-conservative forces, here only. If we
Ma'am,
talk about the, yes, Aram.
sorry to interrupt, but weight will be conservative force?
Yes, weight will be conservative force. Weight is a conservative force. Because see, when you apply weight or whenever weight is there, that is also depending upon the initial and final. Whatever is there at a certain height, that will be below. And even if you change the plane, if you incline it, make it at an angle anywhere, that will also be, weight will always remain same. If it is mg, at any point on earth it will be mg. So weight is also a conservative force. That's why we apply potential energy over here. All right.
Yes, ma'am.
Okay. Now opposite to this non-conservative force, it will depend upon the path. Just opposite to what you have studied for conservative. So non-conservative work done depends on path. Now, how are these portions that we are studying important for you all? Because in your questions, you will be provided through a conservative force, or it will be written, something will be written, and then it will mention you this has been done conservatively. So meaning of that conservative and non-conservative is this only. This depends upon the path. It means this is some A point, this is some B point. One path is this straight line path. This is first part. One path is this. If it's a conservative force, both of these are equal. Work done does not depend upon path. But in case of your non-conservative force, these are unequal. Both are unequal non-conservative forces. Work done will not be the same. Also, work done is closed path will also be non-zero. There will be some value. Work done in closed path is non-zero. The weight was 0 there. So if it's a closed path, let's say A point is there, B point is there, and the body is reaching back to A point. So for closed path, work done will be non-zero. So now we can start with the potential energy. But before that, note down these points for conservative and non-conservative forces and remember these points. Wherever you're not able to understand, make sure that you get your doubts clear. These are very basics for your physics. Gravitational forces, most of the forces are conservative forces only that you have. And gravitational force that we are, potential energy that we are going to study, it is totally based on conservative interaction. Okay, now coming to potential energy. So as we have already discussed in the last class also, I had discussed this with you, that mechanical energy comprises of two types of energies. One, you have kinetic energy. Other types of energy that you have is the potential energy. So kinetic energy we have already covered, work kinetic energy theorem we have already covered. So same thing, potential energy we have to do, and the types of work, potential energy theorem and all these things. Now see, potential kinetic energy came by, what was the reason? Kinetic energy came into existence because of motion. As there was change in the motion, as the body moved, as there was a change in velocity, we obtained kinetic energy by the formula half mv square. Wherever there will be an interaction, a conservative interaction. Interaction means any type of force that will be exhibited by any system. There you have potential energy. Otherwise, you remember potential energy if there is any change in shape, size, or any change in the configuration of the body, then you have potential energy. But that will not help you solve your numericals now in class 11. For your 9th standard, that definition was fine. Let me write down the definition which I am telling. Energy possessed by a body due to its position or size, you can say, or configuration or configuration in a field. Like you can give any example of energy where any type of conservative force is applicable. Like gravitational force is a conservative force. So you will have gravitational potential energy. When we'll do gravitation, we'll see this will also come. In class 12, you have electrostatics, right? So that is not just electrical energy, you have electrical potential energy, because electrostatics, the electric force is conservative. So you get electrical potential energy. All right, so all the energies just convert. But this definition is not sufficient for you to identify whether actually a body is having or possessing potential energy or not. You have to see conservative interaction. Energy due to this, you have to remember conservative interaction. Now, what is meant by conservative interaction? Conservative means same, conservative force. Interaction means forces. So when conservative forces act in a system, that is the energy that is possessed as potential energy. For example, let's say this is Earth. There's a ball that has been raised. So we say no, MGH you must have heard of somewhere earlier in your 9th, 10th classes also. MGH is there. What is potential energy? You used to learn kinetic energy is half mp square and potential energy is just MGH. No, potential energy is not just MGH. That is specifically gravitational potential energy is one case. That was also not gravitational potential energy. Gravitational potential energy is one specified case that we'll see in gravitation in detail. But right now, if these are two forces, what will happen? If let's say this is Earth, this is a ball, both will have force of gravitation. It means here a potential energy will be there. Or let's take one more example. Let's take the example, I have a positive charge. And I have, let's say, another positive charge only. I have these positive charges with me. How can I know the fact that will potential energy exist in this system? There is no change in shape. There is no change in size. The charges are also not moving that I can consider it as kinetic. There are no conditions. But one fact I know, charges will exert on each other electric force So it means if electric force will exist, then there will be, due to the repulsion, both are positive charges, so there will be repulsion. But remember, only kinetic. Why? Okay, why? Any idea why non-conservative forces cannot possess potential energy? C class. Reason, no? Why aren't we considering not non-conservative forces? Why are we only focusing on conservative forces? The reason lies here within the dissipation of heat. In your conservative, why have we named the term conservative? Conservation of what? It's the conservation of heat. No heat is escape. So those forces where no heat is escape, you call it as conservative forces. The forces are said to be non-conservative, where you have the forces heat getting dissipated. Heat is dissipated. Like if we talk about friction, keep your hands rubbing like this. You see your hands become warm. Keep on rubbing your palms like this against each other. Your palm becomes warm. Reason, frictional force is a non-conservative force, and non-conservative force have tendency to dissipate. That's why continuously we are using potential energy under under conservative, not non-conservative. Yes, Wazia, where were you?
Yes, ma'am.
Exams are going on or what?
Yes, ma'am. Exams चल रहे थे.
अच्छा, ठीक. So now you will be regular. हो गए exams over या अभी बचे?
Yes, ma'am. सारे हो गए.
ठीक. Okay, so why are non-conservative forces not possessing potential energy? Because work done against conservative force, whatever is the work done, no, against any conservative force, it gets stored in the form of potential energy. It gets stored in the form of potential energy. So there is no wastage. There is no wastage. Work done conservative force, work done against the conservative force, that is stored in potential energy. But if work is done against non-conservative force, then it will dissipate as heat. Oh, I didn't give you example of non-conservative. No, friction. Friction force, viscous force. Viscous force we'll see when we'll do mechanical properties of fluids. There you have viscosity. That is exactly friction for fluids. So this is just the difference. That's why we are focusing on this only. Now, see, one more thing. Internal and external force also you should remember. But for remembering internal and external, see, internal force means any force that is a part of system. Now, what is meant by system and surrounding? Let's say right now I am considering a system where sun, earth, and moon are there. Means sun is there. Around the sun, the earth is revolving, and around the earth, this natural satellite, that is moon, is revolving. So now I'm not talking about anything else. Is in the universe only these three things that exist: sun, moon, and earth? Definitely not. There are so many other planets, there are so many galaxies, so many things. But when I'm saying my system, I am just considering, I'm not focusing on any other planet. For me right now, I am just focusing on these three. None other planet is involved over here for me. So my system is what? System is sun plus earth plus the moon. So if sun exerts a force on earth, so this is a force within the system, so you call it as internal force. Forces within the system. Forces within the system. if Earth is exerting a force on Moon, that is also internal. If Moon is exerting a force on Earth, internal. But if I am saying Jupiter is exerting a force on Earth, now Jupiter is not a part of my system right now. So Jupiter's force will be external force. This is a very big example. If you take a very small example, let's say my system, for me, the system that is there, for example, is a person who is walking on road. Now this person, this is my system right now. This is my system. So normal reaction will balance the gravitational weight. These are all the internal forces that are occurring. But if I say another person pushes this and exerts a force. So now this force will be external force because that person is not a part of my system. So system means specifically which is the area under observation. That you'll study in, I think, states of matter also in your chemistry. And in physics also you have it in your second book, you have it. Now, one more thing. So similarly to what we have studied for work energy theorem. What was work energy theorem? All the total change in kinetic energy is equal to work done. Same thing you have work potential energy theorem. Total change in potential energy is equal to work done. So if you've understood kinetic energy theorem, so this is not difficult to understand then. So even if I talk about work, potential, energy, theorem, this is exactly what you have studied for kinetic energy. Let's say this is some initial potential energy. This is some final potential energy. Change in potential will be what? UB minus UA. So this change in potential energy will be equal to the work done by the external force. Also, one more thing. If you want to find out what's the work done by internal force, then this is external. And put a negative sign. If you want to find out work done by internal force. Now internal and external forces, I hope that is clear. Clear to you or not? External and internal forces. Yes, class? Yes or no? Should I repeat?
Yes, ma'am.
Clear? Okay. So same thing. This is the statement. I'll write down the statement as well. So potential energy difference is work done. Potential energy difference is work done by external force or negative of work done by internal force, either directly positive external or negative of internal, in carrying a body initial to final position. Any two initial and final position. Now in your exam, if the definition comes, you have to write this exact definition, but do not write these shortcuts which I'm using. PE for potential energy, EXT for external, WD for work done, negative sign, positive sign. No, for exam time, right now also in your notes you can write it as it is, but in your exam you have to write it completely. Write the full forms. Fine, quickly note it down. Also on Wednesday class, see, we have to complete with this lesson. Now we have to at least start with rotation. Otherwise your syllabus will lag behind. So on Wednesday, we'll be having a 2 hours class. So your class will start, I think it's from 5 right now. So it will be from 4:30. 4:30 to the same timings that we have. Your classes are right now from 5 p.m. for the rest of you. So Waziha for you, it will be 7 o'clock. 7:30 पे होती है ना class. So it will be 7 o'clock. 7 to 9. 2 hours class will be there on Wednesday. You'll get a break in between. I'll give you a break whenever you need it. But let's complete a major chunk of work energy, so that from the next week we can. That's why I'm not even taking the test today. Also, I didn't take the test, and so since students are not there, test also I'll take next week. Just let us get ourselves completed with the syllabus first of work energy in par at least.
Ma'am.
Yes, Erin.
Ma'am, can you show the conservative force? Can you just scroll down? I
Conservative.
have a doubt there.
Okay. Conservative force. This
No,
part.
not conservative. Potential. Um, I'm
I'm
not exactly
scrolling.
sure.
I'm scrolling.
Yeah,
Just
yeah, scroll. Yeah, stop.
Hmm.
Yeah, ma'am, as you said that in friction, the energy will be lost, right? It would dissipate heat.
Yes.
But in some cases, we use that heat also, right? Example, bearing
Yes.
ball and all.
Hmm. So that comes under applications of friction force. But your force that will be categorized as non-conservative only. If we utilize the heat energy for some other purpose, that does not make the frictional a less usable force. Frictional force is required. We also know if without friction, the inertias will not be able to overcome. So we require friction force. But these dissipate heat, and that also you can observe even by walking, by just rubbing your hands, even, or if you use in some machines also have dissipative forces. So that is how you classify. This is just a classification. This is not telling you whether a force is a good force or a bad force. Friction force is required, and then these heat energies are also required. In many work engines also these heat energies are required. The amount of heat that comes, that is converted into some form of other energies also in many systems. So that is there. But classification, whether potential energy will exist or not, that is based upon this. Clear?
Yes.
you all have completed, you all can leave. This is for it. Class timings I've already told you half an hour before just for this Wednesday to complete with this lesson. Okay, thank you so much, class.